Air and atmosphere. The entire Earth is divided into lithosphere, hydrosphere, and atmosphere. Our study is limited to the atmosphere, which is actually a blanket of air that extends to about 200 kilometers above us. Thus, we are constantly being pressed by the weight of all that air. Earth's atmosphere. The blanket of air that surrounds the Earth is called the atmosphere. It has 5 major layers. They are: A. Troposphere. This layer is closest to the surface of the Earth, called troposphere. B. Stratosphere. The layer next to the troposphere is called stratosphere. C. Mesosphere. The layer next to the stratosphere is called mesosphere. D. Thermosphere. The layer next to the mesosphere is called thermosphere. E. Exosphere. The layer next to the thermosphere is called exosphere. Percentage composition of air. Air is a mixture of several gases. 2 main constituents of air are nitrogen and oxygen. Apart from them, air also contains other gases. Gases present in air percentage. Nitrogen 78%, oxygen 21%, carbon dioxide 0.03%, inert gases 0.93%, dust particles and moisture variable. Do you know? Till 18th century, it was believed that air was a pure substance. Determination of percentage of various constituents of air by volume. Oxygen and nitrogen. Air is a mixture of gases, namely nitrogen, oxygen, carbon dioxide, water vapor, dust, and smoke as pollutants. While this activity proves that air contains approximately 21% of oxygen, it also establishes that rest of the air, that is 4/5 of air, is composed of gases which do not support burning. As air contains 78% of nitrogen, therefore, it is proved that nitrogen is neither a supporter of burning nor life. So, what is the exact use of nitrogen for living beings? Nitrogen dilutes the action of oxygen. That is, rate of combustion is controlled because of the presence of nitrogen in air. It indirectly reaches plant and is used by plants for making proteins. We all need proteins for growth and repair, as they are building blocks of the body of all living beings. Let us perform the activity to learn about the various constituents of air. Activity: to show the presence of oxygen and nitrogen in air. Take a test tube and mark 5 equal columns in it with the help of a colored pen, as shown here. Place a small piece of phosphorus in the test tube and fix a cotton wool plug over it. Invert the test tube in a beaker. Pour water in the beaker such that the level of water inside and outside the test tube is at 0 mark. Leave the test tube undisturbed for 1 hour in the inverted position. After 1 hour, check the level of water inside the test tube. You will find that the level of water in the test tube rises up by 1 centimeter. Why there is a rise in water level inside the test tube? It is because oxygen present in air inside the test tube slowly reacts with phosphorus to form phosphorus pentoxide. Phosphorus plus oxygen gives phosphorus pentoxide. As the volume of oxygen is completely removed by phosphorus, the pressure of air within the test tube falls. To make up for this loss in pressure, air from outside forces the water up to rise in the test tube. As we have already learned that air contains approximately 20% of oxygen by volume, we can see that the level of water rises by 1 centimeter out of 5 centimeter. It proves that air contains 1 part of oxygen and 4 parts of nitrogen and other gases which do not help in burning. Fact: human activities have caused changes in the composition of air. The biggest changes have occurred since the Industrial Revolution of the 19th century, when people started burning carbon fuels on a large scale. Carbon dioxide makes up a larger part of air today than it ever did before. Carbon dioxide. Air also contains carbon dioxide. Let us perform the activity to show that air contains carbon dioxide. Activity: to show that air contains carbon dioxide. Take lime water in a test tube. It is a colorless liquid. And close the mouth of the test tube with a 2-holed cork. Fix 2 delivery tubes in each hole in such a way that one end of the first delivery tube dips in lime water, while that of other delivery tube should remain much above the level of lime water. Now, either suck air from the end B or attach a vacuum pump to it to suck air. As air is sucked from B, air from A end will bubble into lime water to take the place of displaced air. What do you observe? Lime water gradually turns milky. Since it is the property of lime water to turn milky on absorbing carbon dioxide, therefore, this activity proves that air also contains carbon dioxide. Do you know? The composition of air varies from place to place, and there is no specific formula for air. Water vapor. It is a common observation that as soon as you pour cold water in a glass, the outer surface of the glass first looks misty, and later you see water trickling down the surface of glass. When you pour cold water in a glass, its walls become cool. The water vapor present in air condenses on the outer surface of glass and changes to water, which you see trickling down its surface. This proves that air contains water vapor. The presence of water vapor can also be tested with a blue cobalt chloride paper. It turns pink on coming in contact with the moisture of the air. Similarly, anhydrous copper sulfate, which is white in color, turns blue on coming in contact with water vapor of the air. When the content of water vapor increases in air, we say that it is very humid. When humidity increases in air, the rate of evaporation is very low and it takes longer to dry clothes. On the other hand, during summers, when air is very dry, you are advised to drink lot of water before going out. To check the presence of water vapor in exhaled air, stand in front of a mirror and breathe out with force. You will notice that the mirror turns misty. Why? The water vapor in your warm breath condenses on the surface of mirror and mirror gets misty. In winters, your breath comes out like smoke because air is so cool that condensation of water vapor is immediate and condensed water vapor looks like smoke. Do you know? It is easy to forget that we are surrounded by air. But without it, many of the things that we take for granted could not happen. For example, if you take a car to the moon, it would not work because there is no air. This is why astronauts have to use an electric car when they explore the moon. Henry Cavendish. Henry Cavendish FRS, 10 October 1731 to 24 February 1810, was a British scientist noted for his discovery of hydrogen, or what he called inflammable air. He described the density of inflammable air which formed water on combustion in a 1766 paper on fictitious airs. Antoine Lavoisier later reproduced Cavendish's experiment and gave the element its name. Cavendish is also known for the Cavendish experiment, his measurement of Earth's density, and early research into electricity. Importance of air for all living beings. Till now, we know that all of us need air for staying alive. What does air do to our system that we cannot live without it? To understand the importance of air, let us perform an activity. Activity. Take a petri dish and put a spoon of sugar in it. Leave it in the open. You will notice house flies sitting over the sugar heap. Quickly cover the petri dish with a bell jar so that a few flies remain trapped inside. Leave the petri dish covered with the bell jar having flies inside for a day. The next day you will notice that the flies are dead inside the jar because of the non-availability of oxygen. This activity proves that air is necessary for respiration. Composition of inhaled air and exhaled air. Inhaled air. O2 20.9%, CO2 0.03%, N2 78%, inert gases 0.97%, water vapor less. Exhaled air. O2 16%, CO2 4%, N2 78%, inert gases 0.97%, water vapor more. Air is useful in many ways, like for respiration, photosynthesis, burning, etc. Respiration. Plants and animals both breathe in air. All living things inhaled air and also exhaled air. The oxygen present in air we use to break down food and release energy. The process of breaking down of food to give out energy and carbon dioxide is called respiration. During the process of respiration, carbon dioxide releases. Food plus oxygen. Energy plus water vapors plus CO2. Photosynthesis. Green plants manufacture food by the process of photosynthesis. Plants use sunlight to prepare their food. Food is prepared only in the leaves of plants because they are green. The green color of leaves is due to the presence of a special pigment called chlorophyll. To sum up, photo, light. Synthesis, to make, is a process by which plants use carbon dioxide of air, combine it with water in the presence of chlorophyll and sunlight to prepare their food and oxygen. Do you know why it is not advisable to sleep under a tree during night? This is because both of you are respiring simultaneously during night. So, you may experience lack of oxygen. if you sleep under the tree, because at night no photosynthesis means no oxygen is formed. Photosynthesis and respiration. While respiration occurs during day as well as night, photosynthesis occurs only during daytime. Rate of respiration is very low at daytime. Photosynthesis cannot occur in the absence of sunlight. Air is necessary for burning. When we were discussing about respiration, we got to know that cells burn the food stored in them to release energy. Burning occurs when a substance capable of burning combines with oxygen. We also call the process of addition of oxygen to a substance as oxidation. In our body, oxidation of food takes place slowly. However, when things burn, energy is released at a fast rate. Activity. To show that air supports burning, take a candle, light it, and place a glass jar over it, as shown here. You will observe that candle stops burning after some time. This happens because oxygen present in the air inside the jar is used up by the burning candle. Since no more oxygen is available, the candle stops burning. Burning or combustion. Burning or combustion is a chemical change in which oxygen combines and energy releases in the form of heat and light. When we burn wood, coal, candle, or anything, it releases heat and energy. We use fuel to cook and for transportation. Fuels give off heat and light when we burn in air. Based on their physical state, fuels can be classified into solid, liquid, and gaseous state. A. Solid fuels. Coal and wood are solid fuels which contain carbon. While burning, they produce large amount of heat, light, along with ash and smoke. B. Liquid fuels. Kerosene, petrol, and diesel are very important liquid fuels obtained by the fractional distillation of petroleum. Petrol and diesel used in automobiles and machines. Kerosene is used for cooking and lighting lamps. C. Gaseous fuels. Liquefied petroleum gas or LPG. Rusting. Another slow oxidation process is rusting. When iron is exposed to air in the presence of moisture, a reddish-brown coating is formed on it. This is called rusting, and the reddish-brown hydrated oxide of iron is called rust. As it is evident from the definition, two important conditions for rusting are air and moisture. Let us perform an activity to check it out. Activity. Take 3 test tubes and place some iron nails in each of them. Close the mouth of first test tube with cotton wool containing fused calcium chloride. Fused calcium chloride absorbs moisture and hence it will keep the iron nails dry. Pour pre-boiled water in second test tube. Pre-boiled water is devoid of oxygen. Add a drop of kerosene to stop air from dissolving in water. Add little ordinary water in the third test tube. You will observe after few days that nails kept in the third test tube are getting covered with a brown coating called rust, while nothing happens to nails kept in first and second test tube. The reason is obvious. Nails kept in first test tube got air but no moisture, while in second test tube, nails got moisture but no air. Hence, we conclude that both air and moisture are required for rusting. Rusting is a phenomenon which makes iron weak and it loses its strength. It is prevented by painting oiling, greasing, enameling, and electroplating iron articles, which prevent oxidation of iron by air in the nature. Air pollution. The constituent of air changes due to some harmful substances like carbon monoxide, sulfur dioxide, hydrogen sulfide. This undesirable change of atmosphere is called air pollution. Factors responsible for air pollution: automobile exhaust, thermal power plant, factory byproducts, etc. are responsible for air pollution. Air pollution can be controlled by 1. Growing more and more trees. 2. By using eco-friendly methods. Global warming. The temperature of Earth's atmosphere is increasing due to increase in the concentration of carbon dioxide, which causes global warming. Factors responsible for global warming: deforestation and burning of fossil fuels increases concentration of carbon dioxide and methane.